Welcome to the Insightful Professor. Today's topic is complex retrieval conditions. In this video, we'll expand upon our previous video by explaining how to express complex search conditions or complex retrieval conditions or complex predicates. The purpose in doing this is to more precisely identify or define those rows that we wish to have included in the query result. So in an earlier lecture, we discussed the use of something called a simple retrieval condition. Note that the term single search condition is synonymous with simple predicate, and likewise, they mean the same as simple retrieval condition. So it's just a matter of preference as to how you refer to this particular concept. Now, regardless of whether the predicate is simple or complex, we're going to place it within the where clause of a select statement. And when the where clause is evaluated, or the predicate is evaluated, it will be true or false, and this will determine whether the row is going to appear in your query result. Remember, only those rows where the where clause evaluates the true will be present in the result set. Now, queries developed in this lecture will only involve a single table. We're going to be using the same table that we worked with in the previous video or previous lecture. But keep in mind that in practice, a database usually consists of many tables with all of the data needed to answer a complex question being stored across the database within multiple tables. So therefore, you need to perform some kind of a multi-table operation to completely answer a question. We'll be addressing that concept and solutions to problems of that sort in a later video. So now let's take a look at the course table. Assuming you watched the previous video, this should be review for you. But what we're going to do is quickly go over the course table and just mention a couple of points about this. Each row in the course table corresponds to one row that may be offered at the school for which this course table applies. We can identify one row based upon something called the primary key. And in our illustration here, we're showing that CNO is the column that serves as the primary key. If you quickly examine that column, you'll see that no two rows have the exact same value within the CNO column. Additionally, tables can be related to other tables, and the course table is no exception. The course table is related to the department table, something we've mentioned in the previous video but haven't shown you. We're not going to show you now either. We're just going to mention that one table may be related to another table. Relationships are going to be captured in a relational database through a mechanism called a foreign key. In this case, C department is the foreign key in the course table that serves to identify the related row in a department table that is responsible for or represents the entity that is responsible for the particular course. So C department is considered a foreign key that's used to capture the relationship. Notice that additional columns are often present in the table, and in this case, the columns of credit and lab fee are numeric, which means we perhaps could do arithmetic with them or something of that sort. And C name and C description are character strings. So again, just to show you that there's a little variety in terms of the data here. Well, let's move on. The concept that's going to be most important to understand in this video is something called a Boolean operator. So when we formulate a query, unless the query expressly formulates a predicate or condition that involves the primary key or some other unique valued column, then what will happen is you could possibly retrieve multiple rows even though you've included a search condition or predicate in your query. If you include the primary key, then you're going to get no more than one row. So in practice, what we'll see is multiple search conditions will be necessary to precisely define the row or rows of interest to us, and that's what this video is all about. Now, how do we express the multiple conditions? Well, we start off by understanding simple search conditions or simple predicates, and then we connect them or join them together in some way using what are called Boolean operators. And the two Boolean operators that are used for that purpose are and or. Additionally, there's a Boolean operator called not, which we'll talk about in this section, and that is used to kind of negate the condition expressed by a predicate. That'll all become clear as we go further on, but that's what we're going to be talking about here, and, or, and not. If you've worked with programming languages or some other kind of tool, you may have already encountered this, and I'm sure the logic makes a great deal of sense to you, or will make a great deal of sense once we start to show it, because you've probably seen it in other situations. Let's start with and. So the and connector, or the and operator, is presented in this particular query. In this query, the intent is to retrieve rows from the course table, where we've identified two conditions that must be satisfied by any row for that row to qualify as appearing in our result set. First, the condition says the lab fee of the course must be equal to 0, and second, the department must be equal to CIS. Let's go into the database and try this out. So we select from the course table where the lab fee is equal to 0 and the sponsoring department is equal to CIS. And we go ahead and fire that up. And the first thing we observe is the two rows that we retrieved do meet both conditions. Here we have course C33, which has a lab fee of 0 and a department of CIS. Course C44 likewise has a lab fee of 0 and a department of CIS. To see that this really worked, let's go back and revisit the entire content of the course table. Remember, there are 14 rows, so we're going to see all of them here. And let's remember the two conditions that we want to consider. Lab fee is equal to 0 and department is equal to CIS. Now notice there are many rows that satisfy the condition of department equal to CIS. But of those 6 rows in this case, only 2 of them satisfied the second condition as well, both conditions being satisfied. Similarly, there were some additional rows that satisfied the lab fee condition, lab fee equal to 0, but their departments were not CIS. So note that it is possible for a row in a table to satisfy one of the two conditions expressed in an and predicate. Those rows don't appear in the result because in order to qualify for the result, rows must satisfy both conditions. And the only two that did that in this particular example are course C33 and course C44. Now, let's take a closer look at this query. I'm going to take it, and remember the lab fee is 0 and a department is CIS. And we're going to say, let's select from course where department is equal to CIS and lab fee is equal to 0. Same two conditions, but we've reversed the order. Changing the order does not change the question that's being asked. We still get rows C33 and C44. So it doesn't matter which order we list them in. Furthermore, I'm often asked by students, does it have an effect on the performance of the query? Well, remember, that's not so much of a concern to us as to how the data is going to be retrieved, because that's the role of the query optimizer. However, most query optimizers today are quite mature and quite sophisticated, and whether we say department is equal to CIS as the first condition or the second condition does not affect the query's result, nor does it affect the performance of the query. There may be some systems where that doesn't quite hold, but for the most part, we don't worry about that. There should not be a performance impact. Remember, SQL is a non-procedural language, and as a result, we don't really care about how to get the data. Of course, unless we run a query and it takes hours to give us the answer, then we have some concern. But the point is, it's something that we don't need to be concerned about. Okay, so we can change it in either way. In fact, let's take one more little peek here. I'm going to select from the course table, and I'm going to say where the department is equal to CIS and the lab fee is equal to 0, note that we could put both conditions on the same line. It might not be quite as readable when the queries become more complex. I tend to try to put one predicate on a single line just for clarity. But there's nothing wrong with doing this other than it may start to become a bit congested. But notice it doesn't change the behavior. And likewise, if I flip the order of the two conditions, I'm still going to get the same result. So there's a lot of flexibility with respect to the syntax. Okay, let's move ahead. Excuse me. If we take a look at the next example, we again have two conditions, but look at the conditions expressed here. In the previous example, we involved two different columns, the C department column and the C lab fee column. In this case, we have two conditions that involve the same column. Effectively, what this allows us to do is to, again, require that both conditions are true because we're connecting them with AND. But what happens is we're expressing two conditions that involve the same column. Let's go ahead. We're going to get a range of values effectively. Let's select from the course table where the lab fee is, I forget what we had less than 100 and lab fee is greater than 0. Again, the order doesn't matter. And notice what we get is values here that do fall strictly between the 100 and the 0. So this is not inclusive. We don't get courses with a value of 0. We don't get courses with a value for the lab fee of 100 because we said strictly less than or greater than. Think for a moment. Do you recall from the previous video how we could include the 100 and the 0? Well, the answer is to use a slightly different relational operator. Select from course where the lab fee is less than or equal to 100, which would include the 100, and the lab fee is greater than or equal to 0, which includes the 0, and now this expands the result considerably. We're now up to 10 rows in the result, and you can see that there are indeed rows with that upper value of 100 and several rows with that lower value of 0. So that became more, say, inclusive in this case. And again, we could put the two conditions on a single line. It doesn't really matter. Now, we've shown two conditions. We're not limited to two. We're showing AND as kind of a binary operator, one condition and another condition. But we could have something like one condition and another condition and a third condition and a fourth condition and so on. And we effectively have unlimited capabilities as to how many conditions can be incorporated into our complex predicate. The general rule then would be when you have predicates that are connected with AND, all of the conditions must evaluate to true for the entire where clause condition to evaluate to true. So in this example, we're saying that the lab fee must be greater than 0, and also the lab fee must be less than 100, and it must be a philosophy department sponsored course, and finally it must be 3 credits. If any one of the 4 conditions is false, we don't see the row. All 4 have to be satisfied. So let's go and give that a try. Okay, so we get the lab fee less than 0, lab fee greater than 0, department equal to philosophy, and finally the credit equal to 3. We fire it up, and one row meets all the conditions. Is the lab fee less than 100? Well, 50 is less than 100. Is the lab fee greater than 0? Yes, 50 is greater than 0. Is the sponsoring department philosophy? Yes, indeed it is. And finally, is the credit 3? Yes, all 4 conditions were satisfied. Are there rows that might have satisfied 3 of them or 2 of them? Certainly there are. And you can go back and check the entire course table and confirm that for yourself. And you can do that simply by saying select asterisk from course, and then examine those 4 conditions and find out that there are rows for which maybe 3 of the conditions are true. Like, for example, this row from CIS, 50 is less than 100, 50 is greater than 0, credit is 3. We're almost there, but then department is not equal to PHIL. That row didn't make it into the result because it did not satisfy all of the conditions. And that's the principle with the AND. Now, the other condition we have for connecting simple conditions, or the other connector, I should say, is called OR. So with the OR connector or OR operator, we start again dealing with it as a binary operation connecting 2 things. In this case, instead of both of the individual things having to be true, we need only one. It's possible that both could be true and the row will be retrieved, but we need only one. We don't need the whole set of operation, excuse me, or operands, excuse me. Okay, in this particular case, we're looking for those rows in the course table where the department is CIS. That means the course is sponsored by the CIS department. Or the department is philosophy. The course is sponsored by the philosophy department. Note in this particular example, both conditions involve the C department column. As a result, it is impossible for both conditions to be true for a particular row in this particular example, because within the C department column of a row, you can store one value. You could store CIS, you could store philosophy, but you cannot store both of those values in that single column for a single row. Therefore, it is not possible for both conditions to be true in this query. Let's go ahead and give this guy a shot. So notice, by putting the 2 conditions, we get 10 rows. These 6 rows satisfied the first condition of the department being equal to CIS. The final 4 rows satisfied the condition of the department being equal to philosophy. Clearly, there was no case where one row satisfied both conditions. As we said, that's an impossibility. However, remember the course table has a total of 14 rows. There are 4 rows missing here. Remember, the other 4 rows have the theology department. And when we tested these rows, C department equals CIS, that was false. C department equal philosophy, that also was false for those rows in the theology department. So what we have here is something interesting. We express the condition by saying, I'm interested in the courses where the department is equal to CIS, or the department is equal to philosophy. But when we talk about it in natural language, if we were to express this in English, you could say that this result shows us the courses that are sponsored by CIS and the courses sponsored by philosophy. Notice when we talk about it in natural language, we tend to use and, but when we're expressing the condition to evaluate this in SQL, we use or. Keep that distinction in mind because that's sometimes a point of confusion in formulating the queries where you have multiple conditions. When we're looking for at least one of the conditions to be true, but not all of them need be true, or is the way to go. And you have to kind of think that way, even though informally in natural language, you might be expressing the concept a little bit differently, using and, when in reality, or is what is required in the SQL. That's a potential stumbling block for folks starting out. Okay, as with the and, it did not matter which order we listed the conditions, And also, as with the and, we can connect as many conditions as are necessary to clearly and precisely define what we're looking for in the database. So here we're identifying those courses where the lab fee is equal to 50, or the credit is equal to 3, or the department is CIS, or the department is philosophy. And once again, because multiple simple conditions involve the same column, 2 different tests for C department, it is impossible for a row to satisfy all 4 of these conditions in this particular query. Had the final test not involved C department once again, but involved another column, then we could have rows that are retrieved that satisfy all 4. But again, to qualify, we need to satisfy only 1 condition. And I'll leave it for you to try this query out. Now, there's another interesting aspect of OR. OR is said to be inclusive. A row is selected when it matches both conditions. Okay, we've talked about that, but we didn't give a formal name to it. Here's the formal name about what we've been talking: an inclusive OR. Now, notice that in some of the earlier queries, it was not possible for a row to satisfy both conditions, or in the last case, all 4 conditions, because the same column was being examined with an equality condition. So in this case, we're testing 2 different columns, and even though we're using the equality operator, lab fee is equal to 0, department is equal to CIS, it is possible for a row to satisfy both conditions. Okay, and we're saying or, we only need 1, but both could be true. And I think we've seen basically how this works, so I'll just move ahead. Now, the next Boolean operator is not. And this one can be a little confusing. Let me explain what I believe is a good way to understand how this works and to use it. In the previous queries, we expressed a condition, and we could say that that was kind of a positive sense. C department is equal to CIS. And the rows that were retrieved were the rows for which the condition was true. We also can take a little different approach here. If you're familiar with what are called Venn diagrams, that's what we have here. And if you're not familiar with what are called Venn diagrams, effectively that's what we have here. Okay, so this entire little box or rectangle that's shown here is used to represent what we'll call our universe of discourse, the thing that we're talking about, or the things that we're talking about. Let's say that this box or rectangle represents all of the rows in the course table, the entire course table. So if you were to say select asterisk from course and omit a where clause, everything that is considered represented by this box or rectangle would be included in your result. Now, if you include a simple predicate, such as the department is equal to CIS, C department is equal to CIS, then you won't get everything in a rectangle, you'll get a subset of that. And I've denoted the subset here by using this oval in the middle of the box and putting CIS in there. Those are the rows, a subset of the entire table, that would be returned if you included a simple predicate that said C department is equal to CIS. But suppose we want to get the rows in the shaded area. Well, those are the rows where C department equal to CIS does not evaluate to true. Those are the other ones. If we use C department equal to CIS, the rows that would be represented by the shaded area are ignored. Those are not returned. But suppose we want to return them. Well, this effectively is a concept of what we call the complement of a set. So CIS is a subset of all of the courses. If we say, well, let's ignore those, what's left over? That is, what is the complement? Then what we get is all of the rows where the value equal to CIS is not true. This is where the not keyword comes into play. Take a look at how we can use this. So we can think about it by saying, let's take the predicate C department equal to CIS. Those identify the rows that we don't want. Now, if we just say C department equal to CIS, it's almost like, hey, we want these rows. But what we're first doing is saying, I don't want those. Let me tell you which ones I don't want. And now to tell you that those are the ones that I don't want, I precede that predicate with the word not. And that's all there is to it. Let's give this a try and see exactly how this works. Well, let's select from the course table. And remember, we talked about the order by earlier. I'm going to use the order by just so I can put all of the rows together. I'm going to order by C department. Now, when we look at this, you can see all of the CIS rows appear before the philosophy, which appear before the theology. And that's due to the order by. Again, that's a little review, a little refresher from something we talked about in the earlier video. Now, let's take a look at, suppose we wanted these rows that say the department is CIS, just those. Well, that's easy. Select asterisk from course, where the C department column is equal to CIS, and we get those 6 rows. Now notice that we don't get the philosophy, we don't get the theology. But the approach that I'm saying is we first identified the rows that we don't want. Everything other than these would be the ones we want. So if we have a way to take these, whoops, sorry about that, have a way to take these 6 rows and say exclude them, and then show me what's left over. That's what I want. These are the ones I don't want, everything else I want. And this is how we do it. We take this query here and make a slight modification to it. Select asterisk from course, where the department is equal to CIS, identifies the rows effectively that we don't want, and we simply say, okay, those are the ones, get rid of them by putting not before the condition. And notice I do indeed get the other rows, philosophy and theology. So not can appear right before a predicate to say the predicate defines rows that I really don't want, and then to say precisely that you don't want them, put not before it. Now, if we take the query and try something like where C department and put NOT equal CIS, watch what happens. Ooh, we got slapped on the wrist. It doesn't like that. See, the not keyword cannot be placed before the relational operator. We kind of broke up the predicate. Remember, a predicate is really of the form column, relational operator, and value. We broke that up by trying to insert the word not there. So not has to precede the entire predicate. You can't interrupt it. However, this particular situation is such that testing something where you're saying, well, this is not, and we're looking at an equal condition, occurs so often that we have a special relational operator for that, and we don't need the not keyword. So what we could put is C department less than greater than. That would be not equal. And remember, we could also use the exclamation mark equal. So this is the same as using the not keyword. What we did was we used the not equal operator. C department not equal to CIS. Obviously, philosophy is not equal, theology is not equal, so those rows were returned, which is exactly what we wanted, and we did not have to use the not keyword. Here's a quick little test for you. See if you really understand this. Let's suppose I take this, and now I put not as a keyword before my predicate, but my predicate has a not in it. So select from the course table where not C department not equal to CIS. That sounds pretty confusing, and it is. You probably shouldn't do this, but the idea is this is a little quick test to confirm your understanding. Think about what's going to happen. C department equal to CIS will identify the CIS courses. C department not equal to CIS will exclude the CIS courses and show everything else. So now if we say those are the ones that I don't want, and I tell you that by putting not, this says here are all of the non-CIS courses, get rid of those and show me what's left. And what's left if you take away from the original course table all of the non-CIS courses? Well, let's fire it up and see what we get. We get the CIS courses. Now, this is not a good way to write it, but the point is, if you understand this, you understand the principle of not and the approach that I've described here for understanding what we'll call negation. Can be a bit tricky. Okay, let's move ahead. Hopefully you understand the not keyword. And now we've talked about the individual operators. Let's look at situations where we might have queries where the predicates are so complex they include and, they also include or, they even include not, and you've got all three. Well, think about what you might have done with arithmetic expressions. If you have an arithmetic expression that you have to evaluate, where you've got addition, subtraction, multiplication, and division, there's a certain set of rules or operator precedence that has to be considered. You don't just start off and say, oh, the first thing says add this, I'm going to do that. The next thing says multiply. The next thing says subtract. You don't do it necessarily in the order listed. The operators have kind of a hierarchical relationship or a precedence. So what happens is one of them has a higher precedence than another. So you would do multiplication before you would do addition. Right? That's how we evaluate something in terms of an arithmetic expression. Similarly, when we have the simple predicates connected with the Boolean operators and, or, and we use not, the order has to be predetermined for evaluating this. There's a precedence for the operator. In our case, we're showing this at the bottom of our screen, saying not would be the highest, this would be evaluated first, and would come second, and finally or. Just like with arithmetic expressions, you can alter the order of evaluation, kind of override the precedence by using parentheses. We'll see that you can do the same thing here with complex expressions. But let's start with this first and take a look at how this actually works. Okay, in our next example, we're looking to retrieve rows from the course table once again, but notice we have a situation where what we're doing is saying the department is equal to theology, the lab fee is equal to 0, the credit is equal to 6. But the way we're connecting these three simple predicates is a little bit more complex because we are connecting two of them with and we're connecting the third one with or. So what happens? Again, it's just like kind of having multiplication and addition. You do the multiplication before the addition because of the operator precedence. Multiplication has a higher precedence. So we're going to say select the rows from the course table where the department is equal to theology and the lab fee is equal to 0. Both of those are kind of bound together. So we will get theology courses with a lab fee of 0. The or introduces what we'll call an independent condition. We'll get the rows that have a credit value of 6 regardless of the other stuff. Let's take this and look at this in a bit of detail. Okay, so we're looking at a department of theology, a lab fee of 0, credit of 6. And we're going to use our two connectors. We'll go ahead and fire this up. So we're going to select from the course table where the department is equal to, easier said than done, right, is equal to theology, and the lab fee is equal to 0, or the credit is equal to 6. We fire this up and we get 3 rows. Okay, let's examine the rows. First off, department equal to theology and also lab fee equal to 0. Those two things must be true for a row to come in. That's one option. So what do we have? We have department of theology, lab fee equal to 0. This row here satisfied those two conditions. Did it satisfy the third condition? Credit of 6. No, it did not. Remember, what happens is when you have or, you can say this can be true, or this other thing can be true, or both things can be true. The first thing that had to be true because of and was a combination of these two, and that's how this row got in. It satisfied that combination. Alternatively, it could have gotten in solely on the basis of the credit, regardless of its department or lab fee, But we didn't need that, so this one got in with one of the two conditions with or being connected. Now, let's look at the bottom row. The bottom row, Department of Theology, lab fee of 0. Not quite, almost. It's Department of Theology, but the lab fee is not 0. So this one did not satisfy this conjunctive condition here of two things having to be true together, the and. How about the credit is equal to 6? Aha, that's how it got in. Okay, it satisfied half of this conjunctive condition, but it didn't satisfy the whole thing. But with the credit equal to 6, because it was or, that was good enough. In fact, that's the reason for this other row getting it. The credit was equal to 6. It also satisfied half of the conjunctive condition. It had 0 for lab fee, but the sponsoring department was not philosophy, was philosophy, it was not theology. Okay, so two conditions connected with and is conjunction. I used the term, I should have introduced that earlier. Okay, and that's why I'm talking about the conjunctive condition. Okay, let's go back and remember these conditions. And we're going to go ahead and say, well, here we have the same conditions. We've got the department is theology, the credit is 6, we got the lab fee is 0. However, notice they're connected in a different way. Here we're saying that the department is equal to theology and the credit is equal to 6, or the lab fee is equal to 0. So we move them around. By moving them around, we're changing the association. So what happens is department is equal to theology and credit is equal to 6. Those two simple conditions are combined now with and. Both must be true, or lab fee equal to 0 by itself could be true. So let's take a look at this guy. So we've got the department equal to theology, and we've got credit equal to 6, or we've got lab fee equal to 0. Now notice it's the same three simple conditions that we had previously, but we had combined department and lab fee with and then had or as the independent condition introducing credit. Here we're saying department and credit are combined with and or is introducing the independent condition of lab fee. So we've changed the order and changed the way they're grouped. Let's see what we get for the result. Remember with previous query with these three conditions, we got these 3 rows. Now we fire it up. Well, now we get 5 rows. That's because things are treated a little differently. So we're looking for the department equal to theology and the credit equal to 6. Theology and 6, that's here. What's the lab fee? Well, we asked for 0 to qualify. This one got 200, so it didn't qualify on lab fee. It qualified for inclusion in the result based upon the conjunction here, the other two conditions both being true. Okay, now let's look at what else we've got. Anything else with theology and 6? No. So everything else qualified on the basis of lab fee being 0. Even though it may possibly be the correct credit or the correct department, we needed both of those to be true in this example. The only row where both of those were true, department and credit being what we had asked for, is this final row. The other 4 rows all qualified on the independent condition involving the lab fee. So hopefully this is starting to give you an appreciation for how the conditions work together. Now, in the next query, we show you something that we kind of suggested you could do because we could do it with arithmetic expressions and arithmetic operations. You can override the operator precedence, and that's exactly what we're doing here. So we're saying the department is theology, and then we're saying and within and we have a parenthesized expression that is testing the lab fee and the credit, and that is or. So let's take a look at this. Let's select from the course table where the department is equal to theology And within parentheses, we combine two things. We're going to test for the lab fee being equal to 0 or the credit equal to 6 and fire it up, and we get 2 rows. Now, remember this part here. This is a complex condition in itself, so this will evaluate to true or false by itself. That is, lab fee equal to 0 or credit equal to 6. That component, because it's within parentheses, will be treated as something that by itself produces a true or a false. The true or false produced by that parenthesized expression or sub-expression is then combined using and with the evaluation of department equal to theology. So we're saying the department is equal to theology and this other thing, whatever it is, if those are both true, the row comes back. Now, let's look at what we've got. We've got theology, and the lab fee is not equal to 0, but it is such that the credit is equal to 6. So what happened is that row got in on this guy here, lab fee equal to 0 or credit equal to 6, being true on the basis of the credit being equal to 6, not based on the lab fee. So that rendered a true. That was combined with and it used to evaluate if the row was theology, and it was theology and 6. The second row got in on the basis of theology and lab fee of 0. Its credit did not bring it in, did not qualify it. And again, that's a similar idea. The lab fee equal to 0 or credit equal to 6 became true on the basis of the lab fee, not on the basis of the credit. So that true was combined using and with the test of the department for theology, and the row got returned. So the interesting thing that we see here is that we had the test of theology for the department and something else. And when we combined the test for the department anded with something else, that means for the row to get in, it has to be theology. So notice that's kind of an interesting point here, that all of the rows that appeared in the result here were sponsored by theology. Some had a lab fee of 0, some had a credit of 6. There's another way to write this. Sometimes people don't like to use parentheses because it may be a bit confusing. So let's take a look at an alternative way to write this. I'm going to say select from course where the department is equal to theology and the lab fee is equal to 0. Now I'm violating my idea of one predicate per line because I want to show you how these things are grouped. And then we say alternatively, because we're using or, the department could be theology and the credit is equal to 6. We fire that up, we get the same result. And this might be a little clearer for folks than instead of using the parentheses, because we're saying it must be theology and a lab fee of 0, or we'll give you a second choice, and that's where the or comes in. It still must be theology, but the credit could be 6. So notice we're not testing credit in the first expression, and we're not testing lab fee in the second. We're giving two choices. So this is equivalent to what we just showed with the parenthesized expression. So keep that in mind, that may be an easier way to understand. And sometimes if you have a query that someone has written with parentheses and you want to make more sense of it because it's not clear, just think about breaking it out on your own. Rather than formally rewriting it, at least you can do this in your head to understand what's going on. Or you could just write it this way. Because effectively, when the query optimizer does its analysis and concludes how to get the data from the database, it will take an expression such as we've done in the first form and actually transpose it to something kind of like this. Sometimes that's a query transformation we may see happening if we were to look inside and watch how the system decided to execute the query. So don't be alarmed that you're adding more code here. That's not going to affect the performance. Okay, so hopefully that is clear to you. Okay, in the next query, we have all three operators, not, and or, but we don't use parentheses. So in this case, we have a situation where what we have is three Boolean operators, we're not altering the operator precedence by using parentheses, so what will happen is the system has to evaluate this on its own. So what I want you to do is just consider for a moment, look at the query, maybe pause the video and look at this, and say what exactly is going to be returned when I run this query. So go ahead, take a moment and think about that. Okay, so we've got not C department equal to CIS. Select asterisk from course where not C department equal to CIS. Then what did we have? We had or the lab fee was 0. And we had one more condition, which was and credit equal 3. Let's fire it up and see what we get. Well, it had some effect. We didn't get everything. We got 10 out of the 14 rows. Let's see how this worked. Well, the first thing that we can look at is even though there's a not, we could say, well, technically that would be the first thing evaluated. Give me all of the rows that are not CIS rows. And it says or. So what does that mean? All of the rows that are not CIS rows or something else. Well, that means right here, these 8 rows, the 4 philosophy and 4 theology, should have qualified on the basis of just that first condition, not department equal to CIS. Don't even have to look at the other stuff. The question then is, how did the 2 CIS rows get in? It was not because of the not C department equal to CIS. Well, the alternative, involved testing the lab fee, the credit, and both being true. So, for the non-CIS courses to get in, we don't care what their lab fee and credit is. They're going to get in just by not being CIS. But for CIS courses to enter the result set, it has to be such that both of these conditions must be true. The lab fee is 0, the credit is 3, and sure enough, those 2 CIS rows met those qualifications. That's how they slipped in the door. Okay, note down below that you will see a row for theology that had 3 credit and lab fee of 0. So this row could have qualified the same way the CIS rows qualified, or it could have qualified on the basis of simply not being CIS. So in this case, we finally see a row where all of the conditions have been satisfied for the row to be retrieved. But it's a little confusing without the parentheses. We have to kind of think this through a bit to make it clear as to exactly what's happening and in what order. So we can use parentheses for another reason. Sometimes, instead of using parentheses to alter the order of evaluation, we could add it to provide clarity. Let's suppose we try this query by saying select asterisk from course where, and we want to say, well, the not C department equal CIS was kind of independent of the rest of the stuff. So we'll isolate that by putting it in parentheses, and this hopefully will add clarity. So now we're saying that's treated by itself, or, and what else do we have? Then these two things are combined together with the and. So we'll put those in parentheses. And we get the same 10 rows. Again, just to confirm that for you, we know we got all of the philosophy and theology. Let's make sure we got the same CIS rows and the same CIS rows that were C33 and C44. Yes, indeed, those are the 2 CIS rows that appeared. So this is exactly the same. And let me just bring the 2 up so you can kind of see them together. And we just make it on the screen. Select asterisk from course where, and this was the original query, the not, the or, the and. We altered the query slightly, as you see at the bottom of the display, by using parentheses simply to highlight. Notice the parentheses do not change the order of evaluation. They're serving a different purpose in this example. So parentheses can be used to add clarity rather than to alter order of evaluation. So don't be afraid of using the parentheses, even though you're not altering the order. But if it makes it clear to you, the idea is get the correct query out there. Make sure you're asking the question correctly. Okay, another one on page 17 where we have parentheses. Now this one does have an effect on the operator precedence. And the reason here is we have one condition, department equals CIS, a second condition, lab fee equal to 0. These two conditions are connected with and putting that whole expression, that conjunctive expression within parentheses causes the and to be evaluated before the not. Now, what does this do? You should be able to figure this out from what we talked about. Within parentheses, this expression is identifying a set of rows. What rows are we identifying? The CIS-sponsored courses that have a lab fee of 0. The not says, discard those and give me everything that's left over. So the parenthesized expression identifies a subset of rows, the CIS courses with a lab fee of 0, and then the not says, throw those away and show me everything else that remains. Let's try this out. And we're going to say not C department equal to CIS, and we have an and what we're testing is lab fee of 0 as the second condition. Now let's see, we did not get all of the rows in the table. We have 12 out of 14. Which rows did not appear? Remember we said identify the CIS rows with a lab fee of 0, throw those out and show me what's left. Notice we have 4 of the 6 CIS rows. Which ones do we have? The ones where the lab fee is not equal to 0. Now if this is not quite clear, let's take a look at the query that might have been a preliminary step here. Let's say where, and we'll use these two conditions here. So what we're doing is saying, let's identify from the course table the rows that satisfy these two conditions. The department is CIS and the lab fee is 0. It identifies precisely C33 and C44, those two rows. Then, by putting the not before this whole thing, which is what our current query actually did, we said, ignore those and show me the rest. And sure enough, look at the two rows that are not here, C33 and C44. So hopefully that makes some sense. It's using the same approach as we were talking about, where you have a condition, identifies a set of rows, and then you say, get rid of those and show me everything else by negating it. And that's the principle behind this. So I think that's pretty neat. So it can be a bit confusing, but if you take it step by step, I think understanding queries and being able to write them on your own can be achieved. Now, that's pretty much all we need to talk about for and or not, the Boolean operators or the Boolean connectors. But for completeness, we're going to mention a couple of other special operators. These are kind of, say, redundant in that their functionality can be achieved or attained without using the special operator. But you want to be aware of how these things work just so you have a taste for them. So for all practical purposes, what we're going to see is when we start using this in to list values, we are not limited to, say, 3 as we're showing here, but the list can go on and on and on. So the in keyword, what does it do? It provides a convenient way of asking the system to select a row if a given column contains any value in a set of values, like 2, 6, and 9, the 3 that I've listed here. But I just noted we're not limited to a small number. We could have a dozen, 100 values in here, whatever might be necessary to perform a test. Now the set of values, as far as the syntax is concerned, would be enclosed in parentheses, as you see in this example. And the set of values can be numeric, if we're dealing with a numeric column, as we are in this case, such as credit, or they could be character strings if we were testing something like the description or the course name or the department. In that case, if it's character data, the values must be enclosed in the single quotes or apostrophes. So let's go and check this out. I'm going to go ahead and run a query that says, let's select everything from the course table. A little bit different than what we have here. I get all the columns. And what we're going to do is we're going to be testing that the credit is in 2, 6, and 9. And what we get is courses with 6 credits. Remember, we only have 3 credit and 6 credit. So we didn't have any 2s, we didn't have any 9s, but it did find rows where it got the 6 for a match and brought that back. Now, I said this is redundant. We don't need this syntax. Let me show you why. Select asterisk from course where the credit is equal to 2, or the row can be brought back if the credit is equal to 6, or the row can be returned if the credit is equal to 9. This is equivalent. So you can see it might be convenient because if I had like 5 or 6 or 10 items in here, then I'm going to need 5, 6, or 10 simple predicates all connected with or. So it might be a convenience operator, but it's not necessary because we could express everything without using the in keyword or the in operator. But that's the basic idea of how it works. The real value of the in keyword is not so much the way we're demonstrating it here, but is when you start to work with a multi-table operation called a subquery. That's where you'll really get excited about it. So if you're excited about it now, just brace yourself for when we talk about multi-table operations and subqueries, because then you'll see a real practical use of the in keyword. Now, the same way that we can negate other predicates, we can negate predicates that involve a test like in or set membership. This one's a little bit different. We had said see department in and put some values. And here notice that we could put the not, kind of break up our predicate. This one you could say not see department in, or you could say see department not in. Now let's take a look at this. We're testing here for the Department of Theology or CIS. So let's say I select from the course table where the department is in Theology, CIS. Okay, so we get all of the CIS courses, we get all of the theology courses. Now the current example we're looking at says let's negate this. So that means we're going to exclude these rows. Take the query, and the way it was done initially here was to put the word not before the word in. Seems like it violates the way we were talking about using the not keyword earlier, but let's see. So if the in the positive sense gave us all of the CIS and all of the theology, the not in says get rid of those and what's left, well, that's how we got the philosophy. Well, the alternative way to write this, which if it's not confusing already, this may make it confusing, is to go back and do it the way we were talking about earlier. Put the not keyword before the whole condition. So notice this one you've got some flexibility as to where you place the not keyword. We get the same result, so we could say not something in, or we could say something not in. Why they do it both ways, I'm not sure. Probably just to confuse people, right? Anyway, keep in mind that this one is a little bit different than what we've seen previously. Now, there's another special keyword called between. We looked at the way of doing a range of tests previously by testing the lab fee, say greater than 0, and the lab fee was less than 100. Then we said we could include a greater than equal, less than equal, instead of a strict greater than or less than. Well, the between kind of simplifies that. Between is automatically going to be an inclusive range of values, including the two boundaries we have here. But there is a little bit of a twist to this that you want to be aware of. So let's see, we're looking for lab fees between 100 and 200. So let me select from the course table where the C lab fee, and we say lab fee between 100 and 200. And sure enough, we get 100, we get 200, plus we also get something in between that. So this includes the two values outside. Okay, so we're getting the two test markers or two test values. They are included within the range. So what this is equivalent to is saying select from the course table where the lab fee is greater than or equal to 100, and the lab fee is at the same time less than or equal to 200. So it's an inclusive range check. This is the equivalent idea of the between. Now, one word of caution here on using the between. When you're using the between, this first value is always going to be compared greater than equal. And the second value will always be compared using less than equal. So what does that mean? It means that if I made this 200 and I made the second value 100, then the query would become where lab fee greater than or equal to 200 and lab fee less than or equal to 100, which doesn't make any sense. So let's take this and show you what I'm talking about. I'm going to reverse the order here. See, the system doesn't say, well, which one is smaller. It just goes ahead and said, I'm going to do it greater than or equal to the first thing, less than or equal to the second. So what it will do is it will treat the query as though you had written it this way. And again, that doesn't make any sense. You're not going to find any rows where the lab fee is greater than 200 and also at the same time less than 100. So therefore, keep in mind that the order in which the values are listed here is very important. And that'll become clear to you if you always think the first value is going to be compared greater than equal. The second value, whatever I put, will be compared less than equal. Okay, so that's the between. And finally, to wrap up the between, what we see is we again have the ability to negate this with the not keyword. And in doing this, we could put not after the column and before the between, just like lab fee not in, we can say lab fee not between. Or we can use the not keyword and insert it before the whole expression in the positive sense. Not lab fee between 100 and 200. Okay, so that's the basic idea on these complex predicates. So let's kind of put it together here, a little summary example. In this example, we've kind of combined a number of things that we introduced. We're selecting a subset of columns. Give me the department, the name, the lab fee, and then a subset of rows. The subset of rows are determined by a whole bunch of different conditions. Department is in CIS Theology Management, and lab fee between 50 and 300, and credit is equal to 3. And then we, for good measure, we kind of throw in an order by. So let's kind of recap the syntax, because we've expanded it ever so slightly here by using a larger where clause. The first clause is select, and select will always identify the columns that you want returned. The second clause is from, and this identifies the table from which the rows will be obtained, hence the columns that you've identified. The third clause is where, and the where is identifying which rows will be retrieved. And in our first video, we had a simple search condition. Now we have a much more complex conditions available to us. We understand how to formulate those and express those in SQL. So that can be coded on a single line if you want to make it confusing to read, or if you want to make it clear, put the conditions on separate lines. And finally, after you've expressed all of the search conditions or predicates, if you want to control the order of presentation, then you can put the order by. Remember, as stated in the previous video, the order by will always appear at the end, the last clause. And that's a pretty complex example compared to what we started out with in the previous video. We started off with select asterisk from course. So we've come a long way in just a couple of videos. Now let's summarize what this video has addressed. SQL supports Boolean operators that allow us to take simple conditions or predicates and combine them to formulate more complex conditions or predicates or search condition. And these operators are and, or, and not. And evaluates to true when the two conditions which it combines both evaluate to true. Or evaluates to true when either one or both of the two conditions that it combines evaluates to true. And then finally we have not to negate a condition. So the way we've expressed it here is kind of interesting. An expression using the not operator evaluates to true when the search condition it precedes evaluates to false, right? Because we're toggling it. Then operator precedence is important, and we mentioned this. You have not is evaluated first, then and finally or. And again, operator precedence can be overridden by using parentheses. So hopefully you found this video to be informative and helpful in understanding how to write SQL queries. And if you have any questions or comments, please feel free to offer those in the comments section. We'll take a look and respond if necessary. And consider subscribing to the channel. And once again, thanks for watching.